This is Lesson 7-9, Special Products and Squaring Binomials. Example number 1. Copy this to your notebook paper. We have x plus 5 times x minus 5. We're going to use the distributive property to find the product. Start with x times x, that gives us x squared. Then x times negative 5 is negative 5x. Continue to distribute. We have 5 times x, which is 5x. And finally, 5 times negative 5 is negative 25. When using the distributive property, if it helps you to draw the arrows, please feel free to do so. Also remember, the line of work on the PowerPoint that comes in color is not required for you to write. We now need to combine our like terms. Negative 5x plus 5x will cancel, leaving our answer to be x squared minus 25. Notice the middle terms cancel. Why do you think this is? Our middle terms will cancel anytime we have a special product. Copy this to your paper. If we have a product where our terms are the same and one parenthesis is positive and one parenthesis is negative, the middle terms will go away. We will now look at this with algebra tiles. You do not have to copy the algebra tiles to your paper. Just watch and follow along. So if we model x plus 5 and x minus 5 on our mat as we have learned with algebra tiles, we can take x times x, which is x squared, x times the negative 5 and x times the positive 5. We get those positive and negative x's that later will cancel. And then 5 times negative 5 gives us the negative 25. So we can see here also with the algebra tiles, the middle terms cancel, leaving us just with x squared minus 25. Notice also this makes a perfect square. We always talked about when completing our algebra tiles, they need to form a rectangle. A square is a special rectangle, and we will see that with our special products when using algebra tiles. Example number 2. Copy this to your notebook paper. We should again see our middle terms cancel because notice our terms are the same, 3x and 1, 3x and 1, or one is positive and one is negative. We have opposite binomials like this where the terms are the same. That middle term will cancel. Go ahead and use the distributive property. 3x times 3x. 3 times 3 gives us 9, and then we add our exponents to make it x squared. 3x times negative 1 is negative 3x. 1 times 3x is 3x. And finally, 1 times negative 1. Remember, you're multiplying, not adding here. 1 times negative 1 gives us negative 1. Combine the middle terms and see that they do actually cancel. 9x squared minus 1 is our answer. Again, see that it does follow the rule that our first term squared, subtract our last term squared, is our final answer. Example 3a. Before we look at squaring the binomial, let's practice looking at order of operations. If we have a binomial, 4 plus 3 quantity squared, let's use order of operations to find the value. 4 plus 3 gives us 7, and then we use exponents. 7 squared is 49. Now determine if this equation is true. If I took 4 plus 3 quantities squared and distribute the exponent, making it 4 squared plus 3 squared, we want to determine if this is equal. We know the left-hand side equals 49. So work out the right-hand side. 4 squared is 16. 3 squared is 9. When you add together the values, 16 plus 9 gives you 25. That does not equal 49. So notice, you are not allowed to distribute an exponent. Copy the information in the box to your paper. Notice here, we cannot apply or distribute an exponent across the parentheses with a plus or a minus sign. Many students confuse this with our exponent properties we've previously learned in this chapter. Many students think this is property number 6 for 3b. They look at that problem as property 6. Notice in property 6 you must have multiplication in order to apply your exponent. So in order to work a problem where you have a binomial square, you will just use what squaring means, times itself. So 4 plus 3 quantity squared, we're going to simplify by squaring the binomial. It means times itself. So take 4 plus 3 times itself, 4 plus 3. Distribute 4 times 4. 4 times 3, 3 times 4, and 3 times 3. Find the value of each of those products. 4 times 4 is 16, 4 times 3 is 12, 3 times 4 is 12, and 3 times 3 is 9. When you add together those values, we see that this equals 49. The same as when we worked it out with order of operations. This shows us that squaring the binomial is the correct way to show our work. You should not distribute the exponent. Example number 4. Copy this to your notebook paper. We have x plus 5 quantities squared. Note, we will not distribute the exponent x squared plus 5 squared. If you need to copy this to your notebook paper to remember this would be the incorrect way to show this work, please feel free to do so. Otherwise, go ahead and square the binomial, meaning times itself. So we have x plus 5 times itself, x plus 5. We're going to use the distributive property to simplify. X times x is x squared. X times 5 is 5x. 5 times x is 5x. And finally, 5 times 5 is 25. Remember, you are not required to write down what comes in color. You may go ahead and write the product of each of the 4 terms. We'll now need to combine the like terms. 5x plus 5x gives us 10x. So our final answer is x squared plus 10x plus 25. Notice the middle terms did not cancel. When working with squaring binomials, you should see a pattern. Go ahead and copy this to your notebook paper. Squaring a binomial, if we have the a plus b quantity squared, it equals a squared plus 2ab plus b squared. In words, this means that the square of the first term plus twice the product of the 2 terms plus the square of the last term. We will now use this rule for problem number 4. Go ahead and label your terms. Our first term is our A, our last term is our B. So we take the square of the first term, x squared, plus twice the product, so that's 2 times the product of the two terms, 2 times x times 5. Finally, we're going to add the square of the last term, so plus 5 squared. So we'll need to simplify our answer. So we have x squared plus 10x plus 25. Notice this is the same answer we found when we used the distributive property. You may choose either method on your practice work. In notes, you must have both methods copied, the distributive method and using the rule. But when you practice in your own work, you may choose either method. We're going to look at the algebra tiles for problem number 4. You are not required to draw the algebra tiles. So notice here we have x plus 5 quantities squared. So we took the x plus 5 and multiplied it with x plus 5. This answer matches what we found algebraically, both using the distributive property and the rule for squaring binomials. We must write it out twice. Squaring means times itself. So take 3y plus a negative 1, multiply it times itself, 3y plus a negative 1. Use the distributive property. 3y times 3y, 3 times 3 is 9, and y times y is y squared. 3y times negative 1 gives us negative 3y. 1 times 3y, that's negative 1 times 3y is negative 3y. And then finally, negative 1 times negative 1. Be very careful, you're multiplying. That gives us a positive 1. Finally, combine your like terms. We have 9y squared plus a negative 6y plus 1. The simplest way to write this answer is 9y squared minus 6y plus 1. We will now use the rule for squaring the binomial. You must have both this and the distributive property in your notes. So the rule says we take the first term squared, so that would be 3y squared. You must use parentheses to show you want to square the whole thing. The 3 gets squared and the y gets squared. Plus twice the product of the two terms. So 2 times 3y times negative 1. Finally, we're going to add the square of the last term. So negative 1 squared. The negative 1 is our base, so it must be in parentheses. Simplify your answer. 3 squared is 9, y squared is y squared. 2 times 3y times negative 1 is negative 6y. Finally, negative 1 squared is positive 1. So our final answer is 9y squared minus 6y plus 1. Example number 6. We have 3a plus 2b quantities squared. Be especially careful when working with multiple variables. Go ahead and write it out twice. That's what squaring means, times itself. So we have 3a plus 2b times itself 3a plus 2b. Use the distributive property to simplify. 3a times 3a is 9a squared. 3 times 3 is 9. A times a, add the exponents, you get a squared. So 3a times 2b. 3 times 2 is 6. A times b is ab. 2b times 3a. 2 times 3 is 6. B times a, write that in alphabetical order, ab. Finally, 2b times 2b, or not to be. 2b times 2b is 4b squared. Again, 2 times 2 is 4. B times b, add the exponent. We'll combine our like terms, 6ab plus 6ab. When you combine like terms, your answer is that like term. So we get 12ab. Notice this is standard form. We write our answers in descending order by the powers on a. Because a is alphabetically ordered first in front of the b, you look at the a squared, then a to the first, and then all other variables follow. So you have the b squared. Now let's look at the rule for squaring binomials. We take the square of the first term, so 3a squared. You will want to put the 3a in parentheses so you can square the 3 and square the a. Now twice, which means 2 times, the product of the two terms. So 2 times 3a times 2b. Finally, we're going to add the square of the last term. So plus 2b squared. Again, the 2b needs to be in parentheses. So 3a squared, use your exponent property we learned earlier in chapter 7. Square the 3 and square the a gives us 9a squared. 2 times 3a times 2b is 12ab. And then 2b squared is 4b squared. Example number 7. We have 2m minus n quantity squared. You may use either method for this problem. You may use the distributive property or the rule for squaring binomials. Pause the video at this time to try it on your own. Let's check your answers. If you use the distributive property, we'll check that first. You should have written out the problem twice. Check your 4 terms to make sure that you've distributed correctly. We'll now combine our like terms. Negative 2mn plus negative 2mn gives us negative 4mn. Always remember, when you're combining like terms, when you're adding or subtracting like terms, your answer is that like term. We can write our answer 4m squared minus 4mn plus n squared. If you chose to use the rule for squaring binomials, let's check your work now. You take the square of the first term, so 2m squared, plus twice the product of the two terms, so 2 times 2m times negative 1n. Finally, we're going to add the square of the last term, so negative 1n squared. Because our base is negative, it is required to have parentheses around the negative 1n squared. Simplify. 2m squared is 4m squared. 2 times 2m times negative 1n gives us negative 4mn. And then negative 1n squared is positive n squared. Our simplified answer is 4m squared minus 4mn plus n squared. Example number 8. Copy this to your notebook paper. You must show the distributive property and the rule for example number 8. We have a squared plus b squared quantity squared. There's a lot of variables and exponents going on here, so you may want to show extra steps of work that you don't normally show. First, write it out twice. Squaring means times itself. The extra work you're not used to showing, like a squared times a squared, you may choose to show in this case. That way you can take it a step at a time. Continue to distribute a squared times b squared, b squared times a squared, b squared times b squared. You'll need to recall your exponent properties in order to simplify and find the products. A squared times a squared, we add our exponents when we have like bases. So this makes it a to the fourth. A squared times b squared is just that, a squared times b squared. We are not allowed to add the exponents because we do not have like bases. B squared times a squared, you'll want to rearrange those so they're in alphabetical order. And then finally, b squared times b squared, add the exponents. We get b to the fourth. Combine your like terms. 1a squared times b squared plus 1a squared times b squared gives us 2a squared b squared. When you combine like terms, your answer is a like term. Let's use the rule for squaring the binomial. We take the first term squared, so a squared squared, plus the product of the two terms times 2, plus the square of the last term. So a squared squared, a power to a power you multiply. Remember when we learned our exponent properties, I stressed the p, power to a power to multiply, to help you remember. That gives us a to the fourth. Twice the product of the two terms is 2 times a squared times b squared. Finally, we have power to power, again we multiply. Example number 9. You may choose to use either the distributive property or the rule for squaring the binomials. Pause the video at this time to practice on your own. Let's check our answers. If you chose to do the distributive property, I'll show that work first. Squaring means times itself, so write it out and distribute. Be especially careful with your positive and negative signs in this problem. Whew, that one could have been difficult. If you had a hard time with number 9 on your own, be sure to ask questions tomorrow during class. Let's check your work for those of you that use the rule of squaring binomials. It's the first term squared plus twice the product of the two terms plus the square of the last term. Be especially careful when using these negatives. Since our base is negative, we need parentheses. A power to power we multiply, so we have x to the fourth. 2 times x squared times negative 1 y squared is negative 2x squared y squared. Then finally negative 1 y squared. You square the negative 1 and you square the y squared. y squared squared is a power to power, so you multiply. Again, if you had questions on problem number 9, be sure to ask tomorrow during class when we're working on our practice problems. This concludes Lesson 7-9. We have worked with special products and squaring binomials.